Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. By the way, glad some of you guys are enjoying those pre-streams. I just think that's really fun to just sit there and play with the cube anyway. I mean, I'm gonna sit there and do that, whether you guys are watching or not, so it makes sense to just turn the camera on. Anyway, still working on this Fuzzer ROM, and I think hopefully we'll make some additional progress this week. Basically got to the point last week where we... Hold on, I need to open some more terminals here. Actually, I'll just do it out of this one. Make and VBRS. Rusterboy CLI. Target release. Rusterboy CLI. And we can just do /builds testrom.vb. There we go. There's our ROM. So still working on building this test ROM. Particularly, we need to get everything up and running so that it will run the tests that we want to do in pure assembler, so we have full control over the entire environment. And then it bootstraps C a little bit, and then does some display code, which currently just displays a big gray rectangle because the background is set to gray. Running that again, we can make that black. And now I want to set up some of the world stuff, load up a font, all that good stuff. So we've got some stuff to do. We want to set up the world, the first world. Hey, Mr. Toad. And that, of course, shouldn't change the output yet, just because we clear the map data. Interestingly enough, if we didn't do this, we might get some fun stuff on hardware, but we won't on the emulator. No, I haven't missed anything, Mr. Toad. Sorry, looks like a couple guys in chat are lagging behind with me restarting the stream. Sorry for the jump there. I just like to set the proper title on the stream and stuff. Anyway, so we want to do a couple things. Particularly, we want to copy in a font into the right position in memory, in particular character segment 0 from some data that we need. I believe that the register scope has some images in here, in particular a font. And I think these are just some... Yeah, I think we can just pull in this C file. Interesting that they make this aligned, by the way. Disk by 64 at 2. Not entirely sure what they mean by that, but 4096 bytes looks correct. So let's just pull in that font. Go ahead and copy that to our fuzzer directory. And I'm also going to rename it to a header file here. My mouse is being jank. So in here, we'll include stuff. We'll include font.h. And then font tiles. We should have this here. So if I go in here and we'll copy into here from the font, we'll just do 4096, hard code that. And this should compile. Oh yeah, we don't have copy mem. We need to do this ourselves. That shouldn't be too bad. In fact, I'll just do this. Just do this in C. So we'll just do something stupid simple. Actually, That's probably why they did this align by 4, so we could do whole integer moves. So if we do, what was this, unsigned ints? Yeah, we'll do that then. I'll probably need some casts here, but this is going to be fine. Ugh. Also, this is totally the opposite. And I think we need to do this actually. Pointer arithmetic. I think I just increment the pointer if the data type is an unsigned integer. We'll know if this doesn't work. Okay, that compiled at least. Then we need to put in some map data, which will hopefully do some good stuff. The easiest way to do this, honestly, is we'll do this. Or actually, it's kind of interesting. Oh, the map data must be in words. So let's do this. Actually, what kind of integer types do I have here? I don't like typing byte. I like uint8t. Do I have that in stuff? Let's just use u8, actually. Let's do that. That looks good. This is so cool. Sorry about the buffering rep knob. I guess that's the whole phone watching experience. Now I'm hoping that this will actually map to ASCII. Just judging by where some of this stuff is, it might. Actually want to look at the original PNG because it does have uppercase and lowercase. Uppercase would be at 65, which if this is 32 by 32, that would be here. So I think that's correct. So we can just, whoops. That got zoomed in more than I wanted it to. Hold up. That's how it feels, by the way, when I have this big font when I stream. But okay, so we'll set everything to 0, which should be an empty character, which must be why that even worked in the first place. Yeah, definitely empty here. And on 32, we'll have space. Yeah, this is definitely ASCII. Which is really nice because then we should be able to do a basic sort of print kind of function. And I actually want to do that now as well because I want to be able to use that to print all the results. So I think what I want to do, something like this. I think we don't really need anything here, actually. But we can't let this go back to assembler because I didn't put anything there in the test ROM. So we got to do a loop at the end of this. I think what we'll do is something like this. Actually, maybe I'll want this out here for reasons. Oh, yeah, that probably is what it is, Drew, too. Thanks for the heads up. That's the downside to doing that pre-stream. But I still like doing it. So actually what I want is, because we want a position in the map here. We can do a U8 here. I think we need to set this up ourselves. Do this too. Don't mind just having this as part of the clear stuff. But I do actually want to do this. I know this will call this anyway, but I want to make this more explicit. Because I kind of want it to be something like this. Yeah. I like that. Because then subsequent calls to clear will reset that text pointer, which is the most important thing there. So I think I'm not going to do like a full printf. That would be annoying. But we could totally do something like print string. And we can do something like that, assuming this is null terminated. And then this should be relatively easy. Although we might also want to maintain a line pointer because we want it to wrap at the edge of the screen, not the edge of the map. So I'm thinking we can do this as well. We can do something like this. Hey, little bits. Let's do this, and then we'll break if it's 0. Let's do this even. And then we can increment the pointer like that. Yeah, nothing's going wrong on my end, by the way, guys, so afraid not much I can do to help. Do char C. If not C, then we can break. Otherwise, might as well print stuff. So what we want to do, if C is a new line, or print column is the width of the screen, which I think was 48. Then we want to do something like this. So at this point, print map position should be like 48 characters in. I actually want to make this a U16 because I know that's how big these map entries are. That's probably what this is anyway. We may still have to cast that, but we'll see. Then we can do subtract 48 here. In fact, we can even do like this. Like that. So this will be our carriage return, and this will be our new line. And otherwise, we'll print the character. And maybe... yeah, I think this logic will be fine. We'll test it. And then after this, we'll do just something like this. That should do it. And then we'll also increment this after. And we'll do print column plus plus. I think that'll work. The only caveat is that this, if it reaches the end of the line, the map position will still be the end of the line. But I think that'll be okay. And then this is actually else is the case here. So we can test this. Now this will not work for going past the screen, but we can just try some stuff. Add our new lines at the end of this. Without new lines. That almost works how I wanted it to. So a couple things. The first string worked. The next one was at totally the wrong offset. So it looks like this stuff is not right. I think this is why, actually. We actually want to subtract this. That looks way better. Can you really not change the stream quality since I'm not a partner? Because you used to be able to do that. That'd be weird. Anyway, that's about as simple as it gets if you want to implement printing on a system like this. But this is totally usable. Another thing I want to do is I want to be able to print numbers. So I'm going to actually just have a separate print function because doing like var args and some other stuff I just don't want to deal with. Mostly because I don't remember how to do that, and it doesn't really help much. So we'll just do print. We can do print U32. Yeah, word processor. That's exactly what I need to make baggers. So we'll just do. Yeah. And I'm going to do this as hex. And just hard code that. The nice thing is we can reuse print str and do stuff like 0x. And then we'll do the actual value. Now I'm not entirely sure how I want to do this because I'm not. So I know we need 8 digits. Okay. And then we could do something like the digit is going to be the value shifted right 4 times I, right? 4 times 7 minus I. No. Yes. We'll do that. I think that's it. And then we can do if D is less than or equal to 10, or less than 10. Something like this. This would be kind of a funny way to do this, but it will totally work. Actually, we should just fill a buffer. That's way better than doing calls this whole time. So we'll do this. This will be 8 digits plus 1 is 9. And then we can do buff 8 is 0 for a null terminator. In fact, just to make it a little more clear, we'll even do I like to do that, make it more clear why we're doing 0 there. And then we can do, we'll do int D, and then we'll do char C. I'll do it this way, char C. If D is less than 10, then C is A plus D. Otherwise, C is 0. No, wait, it's the other way around. Otherwise, C is A plus D minus 10. And then we can do buff I is C. At the end of this, we can print string, and we'll just give it the buff. And let's make this a little more... Actually, I kind of like this here. We're going to print 0x, then we're going to fill this buff and print that. So now let's try this. It's one of those moments where I forget that I know how to write C. We can do something like print string, some value is print U32, and we'll do fade babe, my favorite 32-bit constant. And then we're going to go ahead and print string with just a new line. Ah. I am having trouble typing. All right. This did not work, and I know why, but my mouse got all screwy, so I got to unplug it. Hold on. All kinds of hardware difficulties today. And I just hit F12, which means the emulator went into the debugger. Kind of funny. So this is what happened, and you'll notice the F is correct and nothing else is. And so what happened here is that I did this part correct when getting the digit in terms of isolating the part of the number that I wanted, but I didn't mask this off so that it just contains the lower 4 bits. And that's why the top digit was correct and then the other ones weren't. And now we got fade babe. Fade babe, you guys. This makes me happy. So what I'm hoping is we can do something like this. I could do the digits like that too, but I'm not that sad about the current implementation. It would be arguably better without the conditional. Yeah, maybe I will change that for the fun of it. And this will just work as is. Oh, what is up with my mouse? Oh, that's annoying. Whoops. Also, it is giving me cast errors here, so I'm going to fix that. What else does it? Oh, it doesn't like that I discarded the const char modifier here, but that's fine because we can actually do that from the. No, we cannot. The source we can. So let's do that. This makes the unsigned in part of this const, not the pointer part. So that's correct. And 123 it didn't like. Probably because we didn't cast this. Like to fix those warnings. They move all that crap out of the way in case there's something you need to read. But we'll do the digits thing. Do something like static char digits 16 is going to be these guys. And of course, that still works as well. Sweet. I'm going to do actually differentiate between hex and not hex because there is going to be a case that I want to do without hex. Exactly, 8 little bits. I'm allowed to change my opinions. So in this case, I'd want to go the other way to print that. Yeah, you know what? Screw that. I'm actually not going to deal with that. And I'm just going to be nasty here. And it's going to be fine. Because I kind of want to format stuff like this anyway. In fact, this will even be like this. So let's see how this is going to look. Yeah, I have shown F# and C#. That was the demo stream. Hey, tourist. Can always have more fade, babe. Can we fit 3 on a line? Let's just see. No, we cannot. Because we're going to run out of lines pretty quick here, I think. If I don't do the 0x prefix. Then we can do a 3-2 line at least. I would kind of like to do that, actually. Just because I think we're going to hit the line limit pretty quick here. So if we do like this. Yeah, so we can get 3 to a line. It's not too bad. I also realize I don't have to do new lines like this every time, but it's easier for me to think of it that way. S2, thanks for the follow. You know what? Let's actually do this too. I'll just make it GR. Just like I think I'm hitting some corner cases in the printing, and I just don't care. I just don't want to fix that. Oh, that's actually what it is. Never mind. We're actually fine with GPR. Then I do want to put that back. Pebcac. And let's also get rid of the spaces here. Just to see if we can make that a little more readable. I think that's not too bad. Let's just see if we can get more on the line. See you, Rep Knob. Bloop. Yeah, not quite. And we'll just put that back. Okay. We'll do 3 a line. Kind of annoying because there's going to be 32 of them, but shouldn't be too bad. So we'll have those. We'll have the status register. What other registers will we need? We're going to want these. Yeah, PC, EIPC, APSW. Actually, PC we won't need to verify because if the code works, then it'll be the same. PC, PSW, ECR. We might want to pull out some of the status registers, but we'll see. Yeah, shouldn't be too bad, actually. This will work, you guys. Hey, Matt. I'm going to be putting extra spaces here, I think. Just because we can. Very nice. So I haven't really thought about how I want to store the registers after we do the tests. I mean, I guess we just need a buffer somewhere. Now, what the cool thing is, I think what I can do is just make an initialized piece of data here. So I think I can do something like this, where I just do static U32. But the initialized data is going to get zeroed out by our bootstrapping, isn't it? That would be bad. That would not be good. I can close this now, I think. Oh, actually, we can't write to initialize data. Unless it gets copied into RAM, which I don't think is what's happening here. Might actually be, though, just looking at this. Because we look for the data start and the data... Where's our data end? It goes into R1 in this case, which is what this is doing. Oh, maybe that is what that is doing. It just copies the data section. In which case, we still can use it for this purpose, but that is kind of interesting. I guess the semantic of the data section is that we would be able to modify it. If I did this, for example, that would force that to be in a different section, I would imagine. Yeah, it didn't like this. Thanks, Rutu. Yeah, I gotta expand on that stuff at some point. Yeah, so doing this in the data section is not gonna work. I'll need to do it differently. Now the nice part is, where's my linker script? I should be able to just define some section that I can use here that wouldn't get zeroed out. Alternatively, I could have this happen earlier, but I really don't want to do that. I might just make my own section here, because I don't think there's anything special about these sections except for just naming conventions, and then however I handle them here. And of course, working with the C compiler, because it's going to produce different sections that match these names. So I think that's not going to work. Yeah, because here it does the end, data end here. Now, if I stick some data after data end and make sure the linker script knows about it, then this won't touch it. And then I'll still get this in the memory map where I hope it should be. I think I can just make this work. Yeah, right now it sticks to BSS right after that, but I could stick my own data in here. That should be fine. Can't imagine why it wouldn't be fine. The reason I want to do this is because I don't think my car has any SRAM, so I can't just use a random region of memory. It needs to play nice with the C compiler. Yeah, Drew2 has rad Vectrex streams. This does V plus size of data plus size of S data. Oh yeah, but that's in the ROM. Whereas this is the actual. Yeah, that's why it does v is dot there. Put this in there. Because this is actually laying out the sections in virtual memory, from what I can tell. Yeah, data VMA is RAM here. Stack is at the top of that. I mean, it'll be funny if this all works. Just thinking res data for our results. Because that's going to be 8 characters, which I believe is the limit. Or I'm actually thinking of PE files. This may not be relevant in this kind of thing, but it should be fine. This no load thing, because there's not actually going to be any contents of this that we care about. It looks like we would just do something like this. I just like copying the syntax here. I think this is just pulling out where these sections start and end here. So if we do result data like a section here, this should be okay. Can't imagine why this wouldn't work. So then we just need a way to specify this stuff, because we need a pointer to this. Not entirely sure how that's going to work. Also, you know what I just realized? We could actually use a portion of video memory to store the results, which I kind of actually like, because we know that the C compiler is not going to touch it. We don't really have to worry about messing this stuff up. I mean, as long as we don't touch it, it's not gonna get messed up. So I think I actually want to do that. I mean, we don't do anything other than set this column table, which is at a certain place in memory, and just set registers how they should be set. Let me look at the memory map here again. Yeah, Dur 2, I think so. Get our text scroll out. Because here's what I'm thinking. We can't touch the frame buffers. We can't set the background segments or window params. We might be able to change the end of that. I don't want to do it in like OAM. Or in the control registers. We could just use one of these character RAM pattern tables. Like this one. Table 3. Why not just store our results in there? I think that would work. And I think this character segment thing here, yeah, char seg 3 should exactly point to that. And a good test for this. I don't know why D's. And then here we'll do something like this. This is marked volatile, isn't it? Actually, it wouldn't have to be here just because it's this kind of memory. It's not actually a register, so that's actually okay. Do we need volatile there, Drew? I don't think we do if it's not a register. I mean, I'm happy we both thought of it. But I don't actually think we need that. Yeah, that's what I'm thinking, tourist. This one shouldn't be a memory mapped address. This one should just be an address into memory. Like, it's not going to be doing any I/O there. It's not backed by a register. It's going to change from anything other than what the compiler knows about. So I think we don't need it. I mean, I'm just bringing this up because I want to be sure. I could very well be wrong. So the easiest way I can do this is set, for example, R1 to a known value. Easiest way to do this is to do these guys. As far as I know. And then this would be store.doubleword, I think. And we take R1 and we stuff it into what should be that address. How would I just like define a constant in this assembler? Okay, so I can just do, for example, something like this, it looks like. And that charseg3 again. What's this? I like little e's. We may actually need to store the results register somewhere. So if we did R2 for this, that would give us 42. didn't like STD. Most people don't like STD. It's probably STW, actually, because it's byte, half word, and word. Yeah. And 2A is 32 plus 10, which is 42. What up, guys? That was satisfying. That's actually really sick. I'm gonna sit here and what's the word? Is wallow the right word? Like to soak it in. What is the word I'm looking for? Revel. I'm gonna revel in it. Bask is another good one. Yes. Bask in the glory that is my one memory thing. My one integer that I wrote in memory. But what is cool about this is this totally proves that this will absolutely work. And I'm actually kind of happy with using the VRAM to store the results because it's a guaranteed area in memory that will totally work for this, that we know nothing else is going to mess with. And then I don't have to worry about the linker script stuff. So I'm actually quite happy with that solution. And the cool thing is, as well, we don't have to worry about the contents of it until we actually finish the tests, because this code is just going to pull all the register values and stuff them in there. The unfortunate part is it looks like we'll need at least one register in order to actually store that. But yeah, we also don't have the stack. But we could also use just other known addresses. So for example, like the first one, actually, how could we do that? I'm just thinking we're going to lose a register when we want to actually store this stuff. And I don't know what that's going to mean, how we're going to get around that. What's the instruction set for this thing? Yeah, it's reg plus displacement. I don't think we're going to get any way to just store into an actual address. I don't think we have the addressing mode for that. Well, see, I thought of the stack. We can't do the stack because there is no stack in the processor of this system. Like, there's no concept of a stack. There's a convention that I believe it's register 3 is used as a stack pointer. So like there is an alias for SP for that register. But that would again mean we're clobbering a register in order to do this. I mean, I understand why, because that totally simplifies the design of the processor itself. But yeah, I can't just use the stack. I totally thought of the same thing. I just didn't mention it because I had that extra piece of information. Could raise an exception. We could use a trap exception. This actually doesn't preserve any registers. We could use a system register, maybe, assuming we would have one with enough bits that we could definitely read back. We could actually use like FEPC or EIPC. Could definitely use one of those. Because we're basically going to assume that there was no At least in the early parts of this, we're going to assume that there was no trap. And even when we do this, we're going to assume that we're not in, well, because we'd still want to read those back. But yeah, we're going to assume that we're not in one of these. FEPC could probably work. Kind of like that idea. Hey, Anarchy. Because FEPC is only used if you have, I think it's called a duplex exception, where you have an exception that happens within an exception handler. And I don't think I ever want to test that with this framework anyway. If I decide I do, then we can pull that out some other way or something, or work around that. Do some tests that go through a different register or something. I'm not really sure. But I think, what was it, FEPC? I think that would work for now, at least. But I'm going to be right back. I am back. And yeah, I think that FPC thing could work. Another thing we're going to want to do is set up the, like the starting register values. And I think the way that I want to do that actually is set up another section. Like I think what I should be able to do is just dump like an include file that would include the initial values, and then should be able to round trip that through something like this. If I can get a block of values from here, I'm going to be pretty satisfied. We can start with just one value though. And in fact, a really easy way to do that would be something like this. Just do one of these. In fact, we can even do dead beef here if we wanted to. And what I'm thinking is that I'm hoping that this will actually be available here. The reason why why I think it might be is because like we get like data start and data end. And it might be that we just have that available. I hope we do. So we could do something like this. Yeah, I don't think the CPU has such an instruction to it too. It would be really helpful. But I don't think this one does. Even when you enter and exit exceptions, it's just going to push the status word on into an internal register even. Doesn't even push it on the stack. So I think do something like this. I think we can just do load word from R1 into R2. That should work if we have that available. All right, so didn't like reg start values. Didn't like that we have those. Wonder if we just need to do that. No, it didn't like that either. How might we make this global? Also, we can make this const. Yeah, Dana Call would know. Let's see. So it'll be GCC C export symbol maybe, or make symbol visibility. Seems like the right kind of thing here. This is for DLLs though, which may not give us what we need. Actually, what was the would not making it static help? Oh yeah, of course. Yeah, C static is limit that to just that scope, isn't it? That's a good call. Still didn't like that. I actually think that might, I'm going to try prefixing this again. Yeah, that works. All right, cool. The reason why this worked, by the way, is that's just some basic C mangling. That's pretty typical. Just something to know. But this is perfect because this gives us exactly like dead beef like we have here. And that shows up here. So this is actually awesome. We're round tripping values through assembler. It's exactly what we need. Because that's what I want to do here, is that we put this here. That's starting register values. And then here we can do something like that. That is pretty rad. Let's just, to test this, let's just do like 4 of these values. And of course, excess elements in the initializer. Easy to fix. Trigraph? Something ignored? Oh, it's it ignored some of this stuff. That's actually a funny warning. Yeah, we're fine. So let's do this. Try and make this a little more general here. Actually, just noticing that I can do 4 on a line, I might do that with the general purpose ones. Just call them G0. Oh, no, because we need G00 because it can be up to 31. So actually, this is fine for this. But we should see the other ones here eventually. Let's make that work. Let's go step by step with this. The nice thing is we can skip R0 because that's going to be 0. Let's use... Let's use R31. Let's do the last one as the pointer. And this should be pretty simple. Do R31 into R1. The cool thing is we can just do offsets. That's pretty cool. We're going to need to do a little more when we make this a little more proper. But if just doing this stuff works, then we're on the right track. I kind of want to just make this up as I go instead of planning it because I'm not really sure how this is going to work all together anyway. Oh, that's so cool to see this starting to work. That's really nice. So let's say for some test data, let's say I would love to also do like an ink bin here for the actual code. But let's just say we did something like move EA. Yeah, this should just be a constant. So 1337 from R0 into R1 just to change it somehow. And then we get 1337 here. This will totally work. Apparently my labels are wrong. They're off by 1. Oh yeah, my labels in the test in the printing thing. Yep, that's absolutely true. Absolutely true. Actually, I do want to do this. And I actually do want to go 0, 1, 2, 3. Because it should be obvious, but I want to be very, very sure that R0 still acts like we want it to. And then this is correct, because it should always read 0 no matter what we put in there. This is so cool. I don't remember I think you have 5 bits even to specify these offsets. Might even have more. Displacement 16, so I actually have 16 bits for that, which is really great because we can do all of this way. This is kind of crap to do it by hand, but I just don't care. In fact, even just using a small subset of the assembler instructions available here is probably a good move, considering I'm not that familiar with writing code for this architecture anyway. So that'll be my excuse. Nice, that should be it. Okay, so we are one too many. And of course, this one is going to cause us some problems. Because we obviously can't write to that value. However, this is not going to change by the time we do this. So I'm thinking maybe this only works into these registers though. So here's what I'm thinking. I'm thinking we can do something like, whoops. Do something like this. This into R31. We can read this one into R1. Then we can load, what was the instruction? Load into system register. We should be able to do LDSR R1 into FEPC. And then here I think we can do STSR FEPC into R31. Just want to see if that builds. It accepted it. I think that's a good sign. So we can basically do the same thing here, where we load R31 into FEPC. Then we can get the results here. Basically do this whole thing again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. $30 and $31. We're not going to do. Oh yeah, we actually have to do this early on here. Actually, how do I want to do that? Oh yeah, so now we have R31's value, and we can just go through any one of these because we've already set it. So we should actually just be able to do store the one from FUPC into R1, and then we should be able to do store word R1 into the final result here. And that's going to be 120. Should be 128. What did I do wrong here? I didn't miss one of these, did I? Maybe I'm just full of it, and that is actually... No, this should actually be correct. This should be correct if it's 124. Yeah, we're good. We're good. It's going to be so cool to have this set up, though. I'm going to feel good about doing these tests. I'm not ready to be done with this emulator, to be honest, but I'm definitely ready to be done with some of these bugs. As you guys can probably imagine. But that will just make the victory that much sweeter. So I think this will basically work. Now we just need to set up some proper values. Let's just do... I don't want to just do that. Actually, this part was still correct. Who needs metaprogramming when you can just do everything by hand? The reason why I'm not doing this in a loop, if in case you missed it earlier, is I don't want to do a print function that prints base 10 numbers. Remember that I have to do this by hand. And I messed up a token somewhere. That's the worst. Here. Oh, check that out. So cool. I don't know where most of these values came from. Actually, I do. They came from the ROM. So that's good. Do something like this. Also, I totally did make this a scope. Oh no, that was to do this. That's okay. So that's a GPR at least. We need a couple more registers here though. Particularly we're going to want the flags and stuff too. And that's going to be a problem because of this. It's going to overwrite some of the flags. But I don't think these loads and stores will. So in this case, I just set PSW to 0, which is fine. And then we get some deterministic value through going through the same setup routine. Don't really care much about that. Although, I think I will do this. Just in case. Just to be sure. But it looks like we can just do PSW through one of these. That seems a bit weird, actually. Oh no, it's loading the status register into PSW. That's fine. But here's what we can do. We can put R31 into FUPC. We can store the status register PSW into R31. We still need this for a pointer. What we could do is stuff that into EIPC. Zero Pent working on that right now, doing some CPU tests, or will be doing so, setting up the framework to do that now. So if we stuff that in EIPC, then we should be able to pull that out again. Here, we can do it this way. So after these registers, we'll have the PSW. Oops. Something like that. And that's more or less what it should look like, I think. Not sure which other registers we might want to include in this. Just want to make sure I did this, read over this again. Annoying to have to go through the register like this, but I'm fairly certain you have to. So we evict the value from R31, store the PSW into EIPC through R31, use R31 as a pointer to store all the registers. Then we can go through R1 to pull the values out of FEPC and EIPC and into these slots here. This should work. This should work. I kind of want to do... Would this do it? I want to see something that'll give us like a carry flag or something. Yeah, because this should load all of that. We can add 1 to R1. And we got at least 1 bit in the PSW. Haha! In fact, we got 0, which is totally true. 1, 2, 4, 8, and carry. Oh, that's perfect because we added 1 to this, which overflowed it to 0, so that would have set the carry and 0 flags. King! I'm happy about that, you guys. Before I move on, and this might be a good time to call it a day, actually. But before I do that, I think I want to try and get this running on the hardware. Now, to do that, we need to pad this, and I think we need to go find the padding tool from VBDE. So we'll dig for that, and then we can add a step in the make file to do that for us. And then with the padded ROM, I should be able to put it on the system. So here's the PadVB tool. And we should be able to do just the automatic one. That should be fine. And let's say we did build testrom.vb. It's the unpadded ROM and then the output ROM. So that should do it. It made a couple of them, which is weird. Yeah, I don't know why it's making 2 of them. Let's just not specify the end or the output value. Yeah, that works. Then we get what we needed. So then I'll go ahead and add this to the make file. And then we'll do I think we just do this actually. I'll make that for make all. Okay, didn't like that. Is that the pad tool that didn't like that? Could very well have been if I did this wrong. No, that should have worked. Oh, I ran the wrong thing. find pad VB, which should have just been in here. So maybe I do that. There we go. I'll actually add a different directory for that. Stick a bin directory in there. And then it'll be /bin/padvb. And if I do a make clean and a make, looks like it all works. Which is so sick, actually. So with that, I should be able to try it on the hardware. And I'm guessing this will actually produce the same values we're seeing. Because the initial ROM values it's loading should just be from whatever's after that array in the ROM. So that should actually be okay. Let's go ahead and I'll fire all that up. Now we wait. It seems to be taking a while. And I may have heard the disconnect sound, so this might be bad. Hold up. Something's being odd here. Wait for this. Here we go. I mean, excited. We could measure that. Just see how long it takes, because we know the file size. And when I upload this to YouTube, we'll know how long it took, too. There's already a difference. This is identical except for the PSW value, which is different because the 0 flag isn't set. I'm going to look into this. Guys, how cool would that be if that was the problem? It totally could be, because if something branched on the 0 flag and the 0 flag was not correct. This looks gorgeous, by the way, on the hardware. But why would this be 9 here? So particularly, I have the code right here. It's just move EA this into this, add 1 to this. And so just to be sure, the value of R1 at this point should also be 0. Yeah, and it totally is on the hardware. Oh, what a cool way to test this. I'm so happy with this. Yeah, I didn't even write the test. So let's just see what happens here. Let me look at the code. So all we have here, the only instructions here is move EA and add. Now if I'm going to do a test here actually. I should actually do that. That's a good point, move away. Before I do any of this, I should actually load this into another emulator. It's actually a good point. So let's try that. I don't remember how to start the other emulators from the command line, but perhaps the easiest way to do that is just to open up the VBDE thing and just pull that up. Because I know like Midnafin has a weird interface and stuff, and I just do not remember how to use that. So let's just see if we can do that. Yeah, because that would actually be a good idea to test that really quick. Let's do it in Reality Boy. What just happened? Oh, it wasn't built. Yeah, LD would have to clear the 0 flag. I mean, maybe that is a difference. What? Probably because I messed up all this stuff. Let's just open the emulators from the tools directory in there. Yeah, Reality Boy is this front end. Let's go ahead and into the corpus. No, it's in my stuff here. Launch. Please launch. Why won't this launch? Come on, really? All right, let's just see what these take on the command line. Whoops, that's the front end. Okay, it's actually 9 in Reality Boy, but it was 8 on the hardware. That's so interesting. And here we have to do all that crap. Yeah, I'm not going to bother with Midnafin. But yeah, here it was 9, just like it was in my emulator. Which is weird, because I don't think this had the same bugs that mine had. In fact, just to test that, we can test Space Invaders in here. Oh, I already had actually some sound that played that I never noticed before. Or maybe it was just different in this emulator. No idea what the key map on here is. Oh, look how buggy that is. That's totally better in my emulator. By the way. Which buttons start? Let's push all the buttons. Okay, the lasers are visible in his, not in mine. So it's at least different. That animation in the beginning, I remember spending a lot of time to get the timing right for that to display correctly. So I'm not surprised that that works in ours. At least just because I know what that took. But this is really interesting. So this is movie A, then add 1. It's really weird that add wouldn't affect that flag. That would be really strange. But let's actually pull up the hardware manual for this, because I want to look at the actual data sheet here. And it would be possible that these LDSR and STSR instructions do affect the flag. But let's find out. I think it's the architecture manual we need. I always forget. So we want to look at the instructions. Don't know if this was the one. Okay, this was. So the only instructions we're doing here, we have add. And we have, in this case, it's going to be a register and an immediate. So this should set the 0 flag. Right, because it does general register 2 is general register 2 plus the sign extended value of this, which would overflow and set this to 0. So this should set the 0 flag. Yeah, that's exactly what I'm thinking, 0 repent. Like, this is worth looking into anyway. The movie A thing shouldn't matter because this would have ran after that. And if this sets the 0 flag, then this should be, that flag should have been set at this point. So let's look at LDSR and STSR. It's going to be really annoying if those do affect the flags. Because then I don't know how we're going to read them. So this just says refer to supplement below. Look at STSR as well. I don't know why I can't search those, but that's fine. This to me says that it wouldn't affect the flags. I wonder if LDSR just would have affected the flags if you were to write into the PSW. Which is what I would have assumed this meant, but something's weird here. Look in the note. If the system register is 5, the value of the corresponding bit of the general purpose register R2 is set to each flag of the PSW. Okay, so this looks like it sets. The value of the corresponding bit of general purpose register R2 is set to each flag of the PSW. That's a bit weird. If I'm reading this correctly, then because this is meant to load a value into the status register. But what this looks like is that if it's the PSW, the value of the corresponding bit of the register R2 is set to each flag of the PSW. Okay, so actually I think this is just saying that when we do this, it affects PSW. Something's weird. Something is very strange here. So 8 little bits, that's what I thought when I read it, but after reading it a couple times, I think it just means it's set. The value of the bits here is set to each flag. Though I think it's really ambiguous, but I think this just means that the reason why it's even mentioned here is because this would affect the flags. But it should set them to the value that we want to set them to. And even then, we're not doing that. We're not doing LDSR with PSW, except here. But that's just setting it to 0. So I think the wording's just strange there. But yeah, so here we move EA into this. I want to try actually just doing this, just to have one instruction here. And in fact, actually, let's do both of these. Let's do this one at a time. And here we should have fade babe here. And the PSW should be 0 because we haven't touched anything. And if that's still going to be 0 on the hardware, then that's nice. I didn't just open 2 of these, did I? No, I didn't. So I got to go find it again. Oh. Something's weird with this. Why can't I interact with any of this? This is totally worth looking into, even if we have a small difference here. Especially stuff that affects the flags, because that would cause like weird branching or... Yeah. Essentially if statements to be executed when they shouldn't be, and vice versa. Yeah, it looks like there's at least one bug here, which is awesome. That means this is already valuable, which should be really cool. Or it's a bug in the test, in which case this is also worth looking into. I shouldn't actually close that tool. Now I have to navigate to the ROM file again. Yeah, PSW 0 and fade babe is correct. I can imagine you going, ho ho ho, baggers. So this, yeah, we should get all Fs in GPR 0 and still PSW 0. But we should get there. That is funny. The padded ROM is 2 megs, which is according to the specs, the minimum ROM size for a Virtual Boy, which is why this does padding. Yep, so PSW is 0, and we get all Fs in the first register, which matches this. So a couple things about that. First of all, I want to look at some of these other register values. But with everything else consistent, the only thing that changes here is this add. That's the only difference. Which is interesting. So it's either a combination or it's something else. So one thing to try. We know what the result's going to be if we do this. We could try this. You know what I'm also kind of curious to try is let's do this and do a sub instead. Didn't like that. I'm gonna hit this because it'll be easier. This is at least searchable, so it's by mnemonic. That way to sub. Oh, we can only sub between registers. That's not helpful. Except I think, no, add sign extends. So we should be able to add -1. So here again, we end up with 9, which is kind of odd. Because I don't think that should have caused overflow. But it should have caused a 0 flag. So like on this, if the hardware says 1, we might be onto something. I mean, arguably, this is like exactly the same case, just with the register swapped, or the arguments swapped. So it'd be interesting to see what the hardware does in this case. Totally possible I got overflow wrong in the emulator. Totally possible. Which would be so stupid. I'm not making any guesses to what it's going to be. But if it's 1 or 8, then we have some kind of predictable difference. And then it's definitely the combination of this move and the add. Yeah, flashing and delay totally just built suspense. Place your bets. All right, who says 1? Who says 8? And who says 9? Boy00 says 8. Tour says 8. Dark Second says 8. If it's 23, I still get the win. I like Move Away 00 strategy with the 23 thing. No, it is actually 8. 8 is the answer, so you guys were all right. Except 8 little bits. It was 8. Which is really weird. So either... I'm trying to think of how we would even get overflow from this then. Or in this case, I think it was the overflow flag and not the 0 flag, which is so strange. Yeah, if we go ahead and look in the V810 thing here. Yeah, so it didn't set the 0 flag. It does set carry. Oh yeah, of course of course that wouldn't cause overflow, but it would cause carry. That's the one. And that makes sense because if we're adding like -1 to 1 and then we do get that wraparound, we will totally get the carry set. So that makes sense to me. But why didn't it set the 0 flag? That makes no sense to me. So if we look at add, which is going to be add immediate, not add this register one. It's this one, add immediate 5. Left-hand side, right-hand side, and then we do add. In this case, I decided overflow and carry were the same. No, that's not true. Overflow is this result of this weird thing, which I would definitely want to get more tests on. Carry is the carry from overflowing add in this case. We know carry is correct. Somehow it doesn't set the 0 flag. It also doesn't set the sign flag. Which we expect in this case. So we get carry, we don't get overflow, we don't get sign, and we don't get 0, which is just weird. Say Drew too. Yeah, we can check the manual again. I didn't see anything in there that mentioned this. Although I could read about the flags again. So here's add. In this case, it's number 2. So adds the value sign extended to word length from 5-bit immediate data. So it's going to take the immediate 5 and sign extend that, and adds it to the word date of general purpose register reg 2, and then stores the result in general purpose register reg 2. So that's this. And then we have the conditions here. 1 if carry occurs from MSB, otherwise 0. 1 if integer overflow occurs, otherwise 0. 1 if GR is negative, otherwise 0. 1 if GR is 0, otherwise 0. No, it's not add I. That's a different instruction. Or in this case, I just called it add immediate. There's a 5-bit one and a 16-bit one. And we're doing the 5-bit one. Yeah, I should match that, but if I do this, just set this to 0, what happens? That is worth trying with void double 0, and I was thinking that as well. We could try that. So in that case, that would be, yeah, setting 0 to this, and we're going to add 1. Actually, I want to add -1 because I still want that carry to happen. So in this case, if the result on the hardware is 9, that's definitely what's going on, which should be stupid. Here we get 2, which makes sense because we get a negative result, so that's why we're getting the sign flag as well. In any case, I'm really glad we set this up now. Even if this isn't the bug, it's definitely a bug. Okay, the value there is 2, which is what we would have expected there. So I don't think it has to do with something so weird here. That one was correct. So the result has to end up being 0. So let's just take 1 and add -1. Let's see what that is. If it were based on reg 0 going in, then that last thing I just did would have given us a different result. Because I added -1 to 0, and then the 0 flag was not set. So let's try this case. And they never say that if it's based on the value coming in or coming out, but it would make no sense if it were the value going in, based on both any sense at all, and also all of the code I've read while writing the emulator. So this will be another test where the add causes the result to be 0. I also haven't tried adding 0 to 0, which would also be a good idea. Because presumably that would if this instruction just doesn't set the 0 flag, then that would also stay 0 if we added 0 to 0, which I think would make sense. Because we've determined the order of the arguments doesn't matter. The overflow, or sorry, the carry works fine. It could also be that if it's carry and the result is 0, then we miss the 0 flag. Guys, I don't think this sets the 0 flag because this was 8 again. I'm going to try adding 0 to 0. In fact, let's actually try this too. No, wait, because does movie A affect the flags? I don't think it did. I don't think movie A does. It might, though. Yeah, movie A shouldn't. So we'll just see if adding 0 to 0 makes any difference. And in this case, we get 1 here. If we get 0 on the hardware, I'm going to bet that this flag just isn't set by this instruction. And this test would also prove that it wouldn't be related to carry, which is why I want to do it. Now I'm a bit iffy on committing this change. Always and 23. Should do. Okay, the file's locked. Yeah. Who thinks it's 0? And who thinks it's 1? Yeah, who waves bets are in. Because it's 0. I'm just going to come out and say it. It's 0, which means it doesn't look like this is affecting the flag. Now, I want to do one more test before this. And that's... I want to see if this either sets the flag to 0 or doesn't affect the flag. So I'm thinking we could do this. And then if this is 1, then we see that add just doesn't affect that flag. It's really funny how this was already somewhat useful. Yeah, we're definitely going to want to try other kinds of ads as well. Which is I don't know if I finished that sentence, but I'm iffy on committing this change until we can get more tests. So I still want to fill this out by doing the fuzzing stuff that I want to do. And I don't think I want to commit any changes that we find from these tests into the emulator until we've done more tests, because I know that I use this internal add function in the CPU implementation that does adding for a lot of different instructions. And if those instructions have different semantics for the flags, we would have to sit here and test a lot of different combinations, and that's exactly what the fuzzing is supposed to be able to do for us. The fuzzing would allow us to basically test all of these things in one go, which would be better. So right now I just want to see if we can isolate this change, and then I'm just going to make the change generally in the emulator. Or actually, no, because the way I just wrote it, I can't remember what I did now. But we'll just see if that changes anything. So I predict it's going to be 1 now. And it's 0. So that means it's resetting the flag, as in setting the flag to 0. So then it would be something like this. Which we need to rebuild Rusto Boy now. Yeah, at least this one ad is, it looks like it's broken on the hardware. Cool find though, right guys? That honestly, even a small find like this is the kind of thing that actually makes this project feel worth it to me, because it's like, this is the kind of thing that adds to the collective understanding of the system. Like we saw that at least that one other emulator we tried didn't match this. So that's pretty cool. Also, we're getting some errors here. This is the kind of hardware quirk that I would love to be able to document properly. Again, I'm not happy with this fix here right now, because I want to test this a lot more thoroughly. But I kind of want to do that by fuzzing and not just sitting here, because I think that this is going to be really tedious. Oh yeah, no, if this if I can get this to be 0 now in the emulator, which this should do, then I'm totally going to test a bunch of games. And if it does fix any of them, I'm going to be very surprised. If several of them don't boot now, I'm going to be less surprised. Yeah, Space Invaders, got to bring that one up. Mario Tennis, of course. It's taking a minute to build. That's why I'm just sitting here talking. Haven't rebuilt the emulator in a while. Some of these take a while. But I'm super happy with this, just because it already validates this approach. So I'm pretty stoked about that. Dark Second, I hope you're right. I don't think you are, but I hope you are. That would be amazing. This is why I keep Rubik's Cubes on my desk. It'd work as well. Been waiting a lot on tests lately, so the cubes have been kind to me. If you guys didn't know, at work, I'm actually working on another compiler. Apparently that's the guy I am now. My demo tool is a compiler. I work on a compiler at work. And I come home and find bugs in Nintendo hardware from the 90s. This is taking a bit longer than I would have expected, and I'm going to do this. Actually, which... just in case. This use is very true. Yeah, that's exactly what I need, Henrik. Compilers and emulators, it's just like it's beard food. Beard fertilizer. Baggers knows what I'm talking about. Except maybe not the emulators part. More general, more general, more general. Ah, it's another interpreter. Every program. So why is clap taking just ages to build? Yeah. I mean, the nice thing is this should stay built once it's built. If you know what I mean. I am actually just going to wait it out if it happened on both targets. Who else is stoked for incremental compilation? Slow clap. Wow. Oh. All right. I'm going to stable rust. By the way, who loads rust up? This guy. To be fair, I've never had a compile that's this slow. So I'm a bit surprised about that one. And that was on nightly, so it could be something odd. So we'll see if this helps. Just building it on stable. I don't think we're doing anything nightly on Rusto Boy. I think that was one of the things I was concerned about. Moment of truth. I would hate to change argument parsing libraries because of compilation time. That would suck. Clap is for argument parsing. Dark second. And it has never been this slow. Like, this is surprising. And me sitting here just like restarting the build. It actually reminds me of this video that was on. It was like a... Oh, it's actually a weird thing thinking back on it. It was like a PSA that like Nickelodeon did or something. And it was like It was almost like a thing that had tips for going on the internet. This would have been in 98, 99 or so. And it just had this thing about how, like, when you click refresh, it has to restart the video from the beginning. And then it would click it, like it had a little pointer on the screen. It would click the play button a few times, and it was just the guy going, if you keep clicking, if you keep clicking, if you keep clicking. And that always stuck in my head for 16 years now or something. Or like 18 years. Oh, we made it! We compiled clap, you guys. Woo! If we did nothing else this stream, we made it through the clap compile. Yeesh. All right. Okay, so now my test ROM doesn't work. So let's try and apply that to just that one instruction and then rebuild it. Oh, come on. Okay, so we'll do this. I'm just going to copy this here. This is the wrong instruction to do this in. Oops. It's this one. Oh, those messages in the chat are funny to me. So this is interesting. That this just breaks everything. What the hell? Yeah, this is stable rest. Just to be sure. We'll check out the lock file. And then we'll stash this. Okay, then it works. This is strange. Actually, a good thing to do here. I'm going to disassemble this. Yeah, so it is this immediate one, I think. Yeah, because it would have to be. Otherwise, it would take another 16 bits, like this movie A does. Okay, yeah. So I'm modifying the right instruction. Oops, wrong thing. Just to be sure. Let's go ahead and take these up there. Okay, that's equivalent. Oops. We'll inline this. Let's go step by step. It didn't like that, and that's because we put this in for value. Should be fine. Whoops. Yeah, it's totally possible that it's some weird condition that I don't understand. So in this case, this would set the 0 to 0. That would be the only difference. From the handful of tests that we've done now. Black screen. So yeah, so I would guess the hardware doesn't always do this. This is so stupid. But here's what I'm gonna do. It wasn't the obvious thing, but something's weird here, and we are able to see some kind of difference. It's 10:30, so I need to go. And next week we know where to continue digging. This would actually be again the perfect place to start with the fuzzer. We can start by doing this exact instruction, which is nice because it's doing adding immediate values to registers. So this should actually be a really nice instruction to fuzz anyway. So Dark Second says try some ROMs anyway. I will, but I don't have much faith in this. Guessing we're just gonna get a bunch of black screens. Oh, Mario Tennis actually started. And we took a graphic corruption. So, okay, I'm done testing. So yeah. Things are a bit weird, but I think this will be a great place to start next week. So thanks guys for hanging out. I think this was actually really fun, and we definitely found that this approach will be helpful. So I'm super happy about that. Anyway, thanks again for hanging out, and I will see you guys next time.